In order to multiply two matrices together, the number of columns of the first matrix must be equal to the number of rows of the second matrix. In other words, if A is equal to row 1, 5, -3, 10, row 2, 6, 4, 0, row 3, -5, 2, 2, a 3 by 3 matrix, and B equals row 1, 3, 2, 5, row 2, -1, 6, 1 is a 2 by 3 matrix, the multiplication A times B is invalid because the inner dimensions are not equal, i.e., the number of columns of A is not equal to the number of rows of B. However, the multiplication B times A is valid since the inner dimensions are equal, i.e., the number of columns of B is equal to the number of rows of A. So, let's go ahead and calculate B times A. Using the outer dimensions of the product B times A, we know that the product will be a 2 by 3 matrix. We can summarize this as follows. If S is an M by N matrix and T is an N by K matrix, we can calculate the product ST because the inner dimensions match, and ST will be an M by K matrix, i.e., the outer dimensions predict the size of the product. The reason we use the number of rows of the first matrix B and the number of columns of the second matrix A to determine that the dimensions of the product BA will be 2 by 3 is that we sort of multiply the rows of the first matrix by the columns of the second matrix. So let's rearrange the screen to make the multiplication a little easier. To find C sub 1, 1, the first entry in the product BA, we multiply each entry in row 1 of the first matrix, in this case B, by the corresponding entry of column 1 of the second matrix, in this case A, and then add the products together. In other words, C sub 1, 1 is equal to 3 times 5 plus 2 times 6 plus 5 times -5, which is 2. To find the next entry, C sub 1, 2, we multiply each entry in row 1 of B by the corresponding entry of column 2 of A, and then add the products together. In other words, C sub 1, 2 is equal to 3 times -3 plus 2 times 4 plus 5 times 2, which is 9. To find C sub 1, 3, we multiply each entry of row 1 of B by the corresponding entry of column 3 of A, and then add the products together. So C sub 1, 3 is equal to 3 times 10 plus 2 times 0 plus 5 times 2, which is 40. Now we move down to the next row and find C sub 2, 1 by multiplying each entry of row 2 of B by the corresponding entry of column 1 of A. So C sub 2, 1 is equal to -1 times 5 plus 6 times 6 plus 1 times -5, which is 26. To find C sub 2, 2, we multiply each entry of row 2 of B by the corresponding entry of column 2 of A, and then add the products together. So C sub 2, 2 is equal to -1 times -3 plus 6 times 4 plus 1 times 2, which is 29. Finally, to find the last entry, C sub 2, 3, we multiply each entry of row 2 of B by the corresponding entry of column 3 of A, and then add the products together. So C sub 2, 3 is equal to -1 times 10 plus 6 times 0 plus 1 times 2, which is -8.